Dear learners, welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapalli, Assistant Professor at Department of Pharmaceutical Science and Technology, Institute of Chemical Technology, Mumbai. So in our previous lectures, we started with the various types of nanocarrier systems. So we finished with the polymer-based nanocarriers. In the second section, we are seeing the lipid-based nanocarriers. In that, we have finished with the liposomes. In our previous lecture, we have discussed solid lipid nanoparticles. Today, we are going to see the nanostructured lipid carriers. We are going to see what are the differences between other lipid particles and the nanostructured lipid carrier systems. In our previous session, the solid lipid nanoparticles, we have seen what are the solid lipid nanoparticles. We have seen some of the introduction on the solid lipid nanoparticles, what are that, and we have seen the what is the composition which involved in the solid lipid nanoparticles. And also we have seen different preparation methods. With that, we can we can make a solid lipid nanoparticles. In that, we have seen high energy based techniques, and also we have seen the low energy based techniques, and further, we have seen the organic solvent based methods. And also, we have seen one case study. There we have seen the improvement of ritonavir in terms of bioavailability after converting into the solid lipid nanoparticles. So today we are going to see the what are the nanostructured lipid carriers. After that, we are going to see what are the types of nanostructured lipid carriers. Then we are going to see the compositions of nanolipid structure carriers, and then we'll see methods of preparations, then we'll see the application, then case study. So here, nanostructured lipid carriers are the second generation of the lipid nanoparticles. Now, what are the first generation? Nothing but liposomes and solid lipid nanoparticles are the first generation of the lipid nanoparticles, which are differ from SLN and other formulations in their composition matrix. Right? So SLNs as drug carriers, which were limited by drug expulsion, nothing but the leakage of the drug from the carrier during the storage. That is one of the major limitations we have studied in a previous session in the SLN segment. And not only that, the unpredictable gelation tendency that leads to the particle growth in the formulation during the storage. So that is the reason the scientists and the scholars have discovered NLCs to overcome all the potential drawbacks of the SLN. Now we'll see the comparison between SLN and the NLCs. With this, you will understand. In previous lecture, we have seen what are the SLN. And SLNs are the basically which contain the lipid which are solid at room temperature and the body temperature. With that, we can enhance the high drug loading compared with the liposomes. Right? So you can see here, these are the drug molecules. See the loading into the solid lipid nanoparticles, right? After the formulation, you will see the high drug loading. But during the storage, okay, so you will see the drug leakage from the carrier. So high crystallinity results in the low drug loading compared with the NLCs, not with the liposomes and other lipid-based formulations. When you compare with the NLCs, now you can see these are the carriers. Now you can see the high loading of the drugs in the carrier, and you will see the higher stability during the storage compared with the SLA and other formulations, especially with the lipid formulations, right? But when you see the structure, both are different. So that is the nature which helps for the high drug loading, which will also control the leakage of the molecules from the carriers. So solid lipids in the SLNs were replaced by the blend of liquid and the solid lipids in various ratios. It goes from 70s to 30 percentage. So here in the SLN, these solid lipids are replaced by the combinations of the liquid lipids and the solid lipids along with your active molecules. Now, how these liquid lipids will help in the hydroloading, and how these liquid lipids will help in change in the properties of the lipid formulations compared with SLN. Now, liquid lipids are oils. Incorporation causes structural imperfection of the solids. Now you can see this side, it is a solid lipid nanoparticles. The surfactant which is represented in a blue color, and the solid lipid which is represented in a green color, and your drug molecule is represented in a light yellow color, right? So, so this is the, you can see the arrangement of the lipid, solid lipid in a carrier, right? So there is no disarrangement, there is no imperfection because of solid lipids. They have the proper arrangement. It is a proper crystal, ordered crystal arrangement in the structure, right? When you use combination of the liquids, lipids as well as solid lipids, now we will see there is a imperfection, there is a change in their arrangement of the crystals. Now we will see these are the less ordered crystalline arrangement because of the liquid. Now we will see this is the liquid lipid, that is the background you can see. When you add liquid lipids, that will disorder the crystalline structures of this SLN. So that imperfection, that gaps will help for the high loading of the drug. Now you can see, you can count 1, 2, 3, 4, 5, 6, 7. So here you can see it will go more than 20, right? So the representation indicates that the drug loading is very, very high because of there is a gap on the structures. So there the drug loading is very, very high, and definitely solid lipid is also is very, very important, that will hold the drug from the leakage. At the end, NLCs also, after finishing dosage form, which comes in a solid in nature, right? So which will prevent the leakage, furnish the high drug loading than SLN. Not only that, it increases its stability. So when you use combination of the liquid lipids and the solid lipids, you will see the high loading in the carriers. So that is one of the greatest advantage of the solid nanostructured lipid carriers compared with the SLNs. Now we'll see the lipids This we will use in case of preparation of the solid lipid nanoparticles. What we do, we melt this and then we disperse in a aqueous phase which contain the surfactant. Now here we'll take solid lipids, we will melt and we'll add liquid lipids which are nothing but oils, and again we'll disperse in aqueous and the surfactants. So these are the examples of the solid lipids. We know all these beeswax, carnauba wax, stearic acid, cetyl palmitate. So all these are the solid lipids which are solid at room temperature. Whereas liquid lipids, so this comes in a liquid. So these two things we need to mix and we need to convert into the emulsion. So these are the two major components we use in the preparation of the NLCs. Now these are the examples which we can use it as in liquid liquids. Now we are going to see the different types of NLCs. So here, based on the drug is going to incorporate, we can classify into three different structures, right? Now we'll see the structural arrangement of the lipids and their changes in the finished carriers, okay? Now we can see here, so this is the first one, you can see the imperfect crystal type 1 NLCs. So here we'll mix the lipids with a different chain lengths or by using either mono, di or triglycerides, and the concentration of the solid lipid is very, very high compared with the liquid lipids, right? So that will induce the imperfection arrangements of solid lipids that leads to the hydrogen. This is a classical example of the NLCs. Imperfect crystal type 1 NLCs, which already we compared in the previous slide with the SLN and NLCs. Now you can see here, these are your molecule, either it may be lipophilic, you can also use even aqueous molecules also, right? So these are the representatives of the various chains of the lipids. When you use different combinations, the chances of imperfection is very, very high compared with the monomer types of the lipids. So that leads to the imperfection. Now we will see these are the drugs. These are the drugs. You can see the high drug loading in the case of the type 1. So imperfect crystal type 1. So this will form these are available in a crystal structure. Now coming to the second type, that is a amorphous type, that is a type 2 NLC, amorphous type 2 NLC, which are prepared by using medium chain length triglycerides along with solid lipids, right? So yes, whatever we use these lipids will not recrystallize after cooling of your finished product. Now, if it is not converting crystals, so yes, obvious, it will convert into the amorphous form. There is no crystalline formation because these oils or these lipids have a property which will not undergo recrystallization, which are called as type 2. Yes, that will depends on the nature of your lipids. So now you can see there is no arrangement of the crystals. There is no crystals in here. Now we can see everything is dispersed, which is amorphous in nature. So that is called as amorphous type 2. You don't see any crystal formation in type 2 because of the nature of the lipids. Now third one is the multiple type 3 NLCs, which forms the emulsion. Nothing but here we use high concentration of the lipids, that is liquid lipids, with less amount of the solid lipids. Now, this high concentration will help to encapsulate your drug molecules because which has a high water solubility compared to the solid lipids so that you can dissolve in the oils and surrounded by the solid lipid. So these are called as oil nano compartments. It will create an emulsion and surrounded by the solid lipid. So these are called as multiple type 3 NLCs. So it have a compartment, different compartments, and that is covered, surrounded by the solid lipid. So these are the three examples: imperfect, crystal, type 1 NLCs, amorphous type 2 NLCs, multiple type 3 NLCs. So I'm showing with one more example, we can understand very clearly. Now we can see the first one is the imperfect nanostructured lipid carriers. So here you can see the solid lipid which forms the crystalline in nature, and also we can see the background. This is the liquid lipid and then drug molecules, right? Which is the crystalline in nature. Now, whereas amorphous, you don't see the any formation of the crystals in the carriers, which is called as amorphous. There is no crystalline nature in with these lipids because the lipids itself they will not form any crystals after cooling, which are comes in the amorphous solid lipids. Then we need to use liquid lipid and then drug, so that all will form in a matrix. The third one is multiple type nanostructure. Now this is interesting. So here your drug is encapsulated in the oils. The oil globules are surrounded or covered or dispersed in a your lipid, that is a liquid lipid. So this is called as a multiple nanostructured lipid carriers, which is a type 3. If you want to know the more information which is available in this given reference, which is a open access reference. Now here we'll see the what are the composition in the NLCs. Now we can see here, we know that solid lipid is required, liquid lipid is required, yes, even surfactant also required. Based on the drug properties, you need to select, on based on the solubility, you need to select right solid lipid, liquid lipid, and the surfactant, right? So we need to decide the preparation method also, right? So as we discussed, thin ultrasonication method, hot melt homogenization, high pressure homogenization, ultrasonicization. So homogenization is the one of the, yeah, here you can see the some of the examples of the emulsification. So these are the various types of the solid lipids and the liquid lipids. These are the surfactants, and these are the various drugs which we can use for the treatment of the various diseases. These are therapeutic purpose. Now you can see what is the greatest advantage is that you can go as a parental, oral, topical, and both pulmonary also possible, right? So you can see the particle size and you can see the drug loading when you go with the as an NLCs, right? So today we are going to see one more case study in the upcoming slides. So these are the various lipids. We can use it as an NLCs. Now here it is a method of preparation of NLCs. Again, we have to prepare lipid phase, water phase, similar to the solid lipid nanoparticles, but you have to melt your solid lipid first, then add your liquid lipid and add your active substance. If required, you can add solvents also. That is a one phase. Then prepare a water phase, add your emulsifier or surfactant into the water as per the requirement. Now, yes, you can select required procedures as we have seen in the previous slide. In the table, you need to say take desired protocol, desired equipment for the preparation of the NLCs. And then you need to cool down, then you will get an NLCs. Small correction here. This is a NLCs. So yeah, same type of methods we can use it because the composition, addition of one lipid is involved in the preparation of NLCs. But the same technique as we prepared for the SLNs, we can use same techniques for the preparation of the NLCs. By using high energy techniques, high pressure homogenization, ultrasonication, high speed homogenization, supercritical fluid method. With this, you can produce the NLCs based on the your particle size. And the low energy, as we discussed, various emulsification methods which will not involve any type of energy for the reduction of the particle size. These are the simplest methods. Organic solvent, these are the various solvents you can use to prepare the NLCs. For more details, you can refer my previous lecture on the methods of preparation of NLCs. So with all this, we can make nanostructured lipid carriers. Now, here we will focus on the NLCs applications, whereas same applications which can also use for the NLCs also. When you have the water insoluble drugs and if your drug is suffering or limited with the solubility and the permeability issues like BCS class 2 and the BCS class 4, such cases, yes, you can also go with the even BCS class 3 drugs also because they suffer with the low permeability. So BCS class 2, 3 and 4, because with this also you can enhance the permeability because you are using the lipids which will enhance the permeability of the BCS class 3 which are highly hydrophilic but low permeable, right? As well as for class 2 you can enhance water solubility, whereas class 4 definitely you need to balance both solubility and the permeability, right? Such cases we know in case of oral drugs, the BCS class 2 class 4 drugs you can modify, you can use different type of the solid lipids. If the drug is very loading with the SLN, such formulation can be used and you can modify into the conventional formulations and you can give it to the patients. Yes, ocular drug delivery also possible for the various treatment of the eye diseases from the infection, inflammation. So even there are the retinal disease also you can use ocular drug delivery systems. Even you can also use as a in situ delivery systems by converting of your drugs into the NLC carriers. You can give it to the anterior side of the eye. So that will definitely enhance the uptake or the permeation through the cornea. Yes, NLs are very attracted with the brain delivery by giving the nose to brain delivery. You can see the high concentration of the drug in the brain because the brain-brain barrier is the one of the major limitation for the all type of neurodegenerative diseases. So in such cases, Alzheimer's and Parkinson's, in such cases, such molecules can be targeted. You can give by the NLCs, by the nose to brain delivery, or by you can also give by the parental route also. So tumor target also possible. You can encapsulate your anti-cancer molecules. You can label with the required ligands, and you can give it as a parental formulation that will reach to the target. With this transdermal delivery also you can enhance the penetration through the skin. And brain delivery already we have discussed. With this we can also make, you can give an oral delivery that will improve the viability of your drugs. Pulmonary delivery also possible to target the COPD, and we know in case of COVID also people have used a lot of antiviral drugs. Such drugs can be encapsulated in NLCs and you can give it as a pulmonary delivery systems. Intravenous obvious, which can definitely you can expect high loading and high control release compared with the NLCs. So here we are going to see one case study. So that is a comparative study of nanostructured lipid carriers for percutaneous administration of the alkaloids. So this is the reference. It is an open access paper. You can go and read more on this study. So interestingly, what the authors did, that they prepared the alkaloid extract from this species, because these active ingredients undergo the metabolic degradation, so that leads to the low bioavailability. And to enhance the bioavailability, so authors converted their active alkaloid extract phytoconstituent into the two carriers. One is with the SLN and then with the NLCs, right? So they have used high pressure homogenization technique to reduce the particles into the nanometer. That is, they have prepared SLN, NLC with the same instrument, and they have used these ingredients to prepare nanostructured lipid carriers and as well as SLNs. Yes, we know that in case of NLCs, we have to use solid lipids. So with that, after the formulation, they got the particle size of 160 nanometer with the drug-loaded nano formulation with the 160 and 176 for the SLN. So interestingly, the particle size is almost same in both cases. Now, yes, they have got the more than 75 percentage of the drug loading, and after that, they have observed the penetration of the drug loaded molecule. They compared these molecules in a carriers. One is SLN, second is the NLCs. So the drug loaded NLCs enhanced 3.27 fold higher compared with the SLN formulations. So after the skin penetration, so this is the result. You can see at different time intervals. The blue color represents the concentration of the active molecule with the SLN. Whereas you can see in the pink color, it's represented the concentration of the active molecule in NLCs very higher, as it represents it is greater than NLCs. So with this, we definitely will understand the NLCs will help for the high drug loading, which will definitely will affect the bioavailability of the active molecules for the treatment. So these are the references. If you want to know more, you can read the various literature, which will help for the understanding of the more on the what are the solid lipid nanoparticles and the what are the NLCs, what are the methods available, and what are the applications which help for the readers. So with this, we will conclude. So today we have learned what are the NLCs, and then we have seen what are the types of the NLCs. That we have seen the three different types of the NLCs. One is the imperfection, crystal, type 1 NLCs, amorphous, type 2 NLCs, and also we have seen multiple type 3 NLCs. And after that, we have seen the composition of the NLCs, and then we have seen the methods of preparation, which are almost similar to the SLN. The difference is the liquid lipid is the extra material we need to add in case of NLCs. And after that, we have seen the applications of NLCs, and then we have seen the case study, which suggests that so NLCs are efficient in terms of the improvement in the bioavailability compared with the SLNs. So with this, we will stop today's lecture here.